Reaching for the stars, the ambitions of Starship. SpaceX's Starship program represents a bold vision for the future of space exploration. It aims to create a fully reusable spacecraft capable of carrying both crew and cargo to destinations like Mars and beyond. This ambitious endeavor holds the potential to revolutionize space travel, making it more affordable and accessible than ever before. Starship's development has been characterized by a rapid iteration and testing approach. Each test, whether a success or failure, provides valuable data that informs the design and engineering process. Static fire tests, in particular, are a crucial step in this iterative journey. These tests involve igniting the spacecraft's powerful Raptor engines while the vehicle remains firmly anchored to the ground. This allows engineers to gather critical data on engine performance, fuel flow, and overall system integrity in a controlled environment. The data collected from static fire tests is meticulously analyzed to identify any anomalies or areas for improvement. This iterative process of testing, analysis, and refinement is fundamental to SpaceX's approach to rocket development. The static fire crucible, a test of might. Static fire tests are a critical milestone in the development of any rocket, but they hold particular significance for Starship. Its Raptor engines, fueled by liquid methane and liquid oxygen, represent a significant leap forward in rocket propulsion technology. These engines are designed to generate immense thrust, allowing Starship to break free from Earth's gravitational pull and journey to distant worlds. The static fire test environment is carefully controlled and monitored. Engineers use a complex array of sensors and data acquisition systems to track every aspect of the test, from engine temperatures and pressures to the vibration levels within the spacecraft's structure. A successful static fire test serves as a crucial validation point for the engine design, the propellant systems, and the overall structural integrity of the rocket. It provides a high degree of confidence that the vehicle can withstand the immense forces and stresses it will encounter during launch and flight. However, static fire tests can also reveal unexpected issues or anomalies. These can range from minor deviations in engine performance to more significant problems that require design modifications or component replacements. S35 ignites, a spark of hope, a cloud of mystery. The anticipation was palpable as SpaceX prepared for the static fire test of Starship prototype S35. This particular test was eagerly awaited by space enthusiasts and industry experts alike, as it represented a significant step forward in Starship's development timeline. The test was scheduled to take place at SpaceX's Starbase facility in Boca Chica, Texas, where the towering Starship prototype stood poised on the launch pad. All eyes were on the live stream as the countdown clock ticked down to 0. With a thunderous roar that shook the ground for miles around, S-35's Raptor engines ignited, illuminating the Texas sky with a brilliant orange glow. The initial moments of the test appeared promising, as the engines roared to life and the spacecraft remained firmly anchored to the pad. However, as the seconds ticked by, whispers of concern began to circulate among those watching the live stream. The duration of the test seemed shorter than expected, and there were subtle but noticeable anomalies in the engine plume and the behavior of the spacecraft. Whispers of concern, anomalies in the fire. As the dust settled and the initial excitement of the S-35 static fire test subsided, a sense of uncertainty began to emerge. SpaceX, known for its transparency and sharing information about its testing activities, remained unusually quiet in the hours and days following the test. Speculation and rumors filled the void as space enthusiasts and industry observers scrutinized the limited footage and data released by SpaceX. Some pointed to the shorter-than-expected duration of the test as a potential red flag, suggesting that the engines may have shut down prematurely. Others highlighted the unusual appearance of the engine plume, noting that it appeared to be more diffuse and less focused than in previous static fire tests. This could indicate a problem with the engine combustion process or issues with the fuel mixture ratio. The lack of official information from SpaceX only fueled the speculation. Was this just a minor hiccup in an otherwise successful test? Or did it point to a more significant problem that could delay Starship's development timeline? The specter of setbacks is Starship Cursed. The S-35 static fire test anomaly, while concerning, must be viewed within the broader context of Starship's development history. SpaceX's iterative approach to rocket development embraces both successes and failures as valuable learning opportunities. Throughout its development, Starship has experienced a series of setbacks, including several high-profile test flights that ended in dramatic explosions. These incidents, while visually striking, have provided SpaceX engineers with invaluable data that has informed design modifications and improved the spacecraft's safety and reliability. It's important to remember that rocket science is inherently complex and challenging. Setbacks and anomalies are an inevitable part of the process, particularly when pushing the boundaries of what's technologically possible. Attributing these setbacks to a curse is not only inaccurate, but also dismissive of the incredible engineering achievements and lessons learned along the way. SpaceX's willingness to take risks and learn from its mistakes is a testament to its commitment to advancing the frontiers of space exploration. Charting the course ahead, implications for Starship's journey. The full implications of the S35 static fire test anomaly on Starship's development timeline remain to be seen. SpaceX, known for its ability to quickly analyze data and make necessary adjustments, is likely already hard at work investigating the root cause of the issue. Depending on the severity of the problem, the S35 test anomaly could result in a delay of several weeks or even months, as SpaceX engineers implement design modifications or component replacements. However, it's important to note that delays are not uncommon in rocket development, and SpaceX has a proven track record of overcoming technical challenges. In the meantime, SpaceX is likely to continue its rapid iteration and testing approach with other Starship prototypes. The company has several other prototypes in various stages of assembly and testing, allowing it to continue gathering data and refining the spacecraft's design. The S35 static fire test anomaly, while a setback, is unlikely to derail Starship's development. SpaceX's unwavering commitment to its ambitious goals, coupled with its iterative approach to development, suggests that Starship will eventually overcome these challenges and achieve its full potential as a revolutionary spacecraft. A legacy forged in fire. The enduring importance of Starship. The pursuit of space exploration is fraught with challenges, setbacks, and moments of both triumph and disappointment. The S35 static fire test anomaly, while a reminder of the complexities of rocket science, should not overshadow the significance of what SpaceX is trying to achieve with Starship. Starship represents a bold vision for the future of humanity, a future where we become a multi-planetary species, capable of exploring and inhabiting other worlds. This vision is not without its risks, but the potential rewards are immeasurable. SpaceX's relentless pursuit of this goal, its willingness to push the boundaries of what's possible, and its unwavering commitment to innovation serve as an inspiration to us all. The journey to Mars and beyond will be long and arduous, but the spirit of exploration, embodied in projects like Starship, reminds us of the boundless potential of human ingenuity and determination.